Hello, this is a tutorial on how to CAD using Onshape for VEX Robotics specifically. So in this video, you'll learn how to insert robotics parts into your account as well as a document and learn the primary tools for assembling a robot as well as how to make polycarbonate pieces and custom parts. So what you're going to want to do first is you're going to want to head over to the link in the description, which will lead you to the VEX Robotics parts folder that I created specifically for this video. So this folder will have all the parts you need, like C-channel or gears, and basically everything that you'll need to create a robot. So once you have this open, you're going to want to head over to the Labels tab. You want to click on that and then head over to the Create New Label. I already have a label created for this video, but once you create it, it'll already automatically be checked for the one you started with, and you're going to want to have to go to the, the next part and then click on it for all of them. I already have a label created, so I don't need to do that. But once you do that, it will look something like this. Now, this will hold all the parts you have in a label, and that'll allow you to insert the parts into a document. So once you have done all of this, you're going to want to head over and create a document by going to the Create menu and clicking on Document. Once you have created your document, it will look something like this. It will have your part studio and your assembly. Now, the part studio is basically for creating or editing parts. You can use this to create polycarbonate pieces or edit existing parts like gears or screws. Now, the assembly is where you're going to assemble your parts, basically. You're going to be combining them and making your robot in the assembly. The assembly is also where you will be inserting your parts. Now, if you go all the way up to the top bar, you'll see an insert, and you can go to, it'll probably open with current document for you, but you'll want to go over to other documents and then click on the label you just created. This will have all of the parts that you need to be able to insert. Now, if we click on structure, we can head over down to the C channel, and you'll see here that you have length and C channel type. This means it's configurable, which means you're able to edit however long it is and what type of C channel it is. So if I want to, I can create a 15 long, which is 30 holes long, and I can make it a 1x2x1, which is a regular C channel. I can generate that, and then once I click on it, it'll go into the assembly. I'm zoomed out, but once I zoom back in, you'll see that I have a full C channel here. I can do whatever I want to the C channel. I can rotate it, I can translate it, or I can just move it freely. Now, let's say you messed up the length you want to be this C channel. If maybe you did it too short when you insert it. You can easily go by right-clicking, going to change configuration, and you can edit the length. Now, if I want to make it smaller, I can easily do that. Or if you want to change the channel type, you can do that as well. Alright, so now I'll start going over the specific tools that you will be primarily using. And those three tools will be the Fastate, the Revolute and the Slider Mate. Now, what I'm going to do is I'm going to insert a gear into the assembly. I'm going to insert a 36 tooth gear, and then I'm going to rotate this to kind of make it look a little similar to what a drivetrain would look like. It would have that angle, and then the gear would probably be on this surface. So if I wanted to, I can use this Fastate to connect this gear to this C channel. Now, all of these tools up here, the Fastate, the Revolute Mate, and the Slider Mate, they all connect it to from one plane to another plane. Now, the Fastate is basically a fasten. It connects the plane to another plane, and it doesn't allow it to move anymore. So if I want to do that here, all I have to do is go over to the plane that I want to select, which will most likely be this one for most people. And now that I'm on this plane, you'll see that a little box appears with different circles around it. To be able to select those circles and get in the middle of the gear, I'll have to first hover over this plane, hold Shift, and then click on the middle circle. That selects the plane, and then I can go over to the C channel here, so do the same exact thing on the middle of a hole, and it'll connect them both. Now, what happened here was it basically did it backwards. What it does is it doesn't really know which angle you want it to be facing, but we can easily fix this by clicking the arrows here, which flips the primary axes and sets it how we want it to be. So that's connected there. Now, this basically can't be moved, but the whole assembly here can be moved. Now, if I want to make sure that a specific part can't move at all, like this, I can fix it, and then it doesn't allow it to move. But the thing that holds the gear to the C channel, because the only thing fixed right now is the C channel, but the thing that's holding the gear to the C channel is the mate. If I were to remove this mate, then it can move freely. But since I still have that mate there, it doesn't move. Even if I click on it, try and translate it, or rotate it, it will not move. And that's the good thing about the Fastate. Now, I'm going to copy this in again, and I'll show you how to use the Revolute mate. So it works the exact same with the plane, where you go up to it, hover over it, shift, select, go over to another hole on the C channel, and that can be any part you want, and then select that. This time, I didn't have to flip the primary axes because it just stayed in its original orientation. But now you see here that the difference between the two doesn't look much, but this one is actually able to rotate. That's the good thing about the Revolute mate, is that it stays connected horizontally. You can't move it on the any other plane besides just rotating. This can be really useful if you want to be able to move wheels around to make sure your things don't hit, or you want to like move a first stage intake. That's very helpful. It can be very useful in a lot of scenarios. Now I'll show you the slider mate. Now it kind of works how it sounds, as it will slide on another mate. So once I do the same thing again, add it to the C channel, then it is connected both this way and up and down, but it will travel on the axes that you put it on. So it will be able to slide back and forth. It's very laggy right now, but as you can see, it will slide and it'll be able to move on this axis freely. Now, one thing you can do about the slider and Revolute mate that's very interesting is you can add limits. So if I wanted to add to the Revolute mate, I can make it so that it can only rotate that much, or it'll be able to rotate all the way with no minimum, no maximum, or it can have a minimum and a maximum. Those are very helpful if you don't want to um, have to keep resetting something all the time, where it always or don't have if you don't want it to like overshoot, that can be helpful for the rotary or the Revolute. And for the slider one, this one's very helpful because there's no mechanism where it's going to be able to slide like this freely, but adding limits simulates that it will um, have an end, I guess. And it's very helpful for building because you don't have to keep measuring it every time you move it. This can also be used for pistons since you have to manually attach the the sliding part for the piston, and you have to manually select that, and you have to add your own maximums and minimums, and you don't want to keep measuring that every single time. So those are really, really helpful. So what I'm going to do now is I'm going to go over the grouping. So this basically sounds exactly how you would think. Now, if this, I'm going to delete the slider, and I'm going to add another uh, Revolute mate. I'm going to add it right on this one. So these ones are, they're attached to each other, but they don't rotate exactly the same. They'll rotate differently. But to fix that, I can select both and then group them. This basically makes them rotate exactly the same, and it can be very helpful if you need two different C channels to rotate the same or two different wheels to rotate the same. So this can be really helpful. Grouping can also be helpful for duplicating things. If we have like these two gears here and we want to copy them and say they didn't already have a group and they didn't have any mates, we can select them, group them, and then they'll be able to move together, and then they'll also be able to be fastened together if I fasten them with a fastenate. So that's very helpful for duplicating. Now, you'll see here, if I get rid of this and that, you'll see that there's an error popping up for the revolute and the group. Now, an error is popping up because both of these gears are already fastened, or they already have a joint or a mate. So, and they don't both need one since they're grouped together. So to fix this error, all you have to do is delete the second one, the second revolute, and then it'll have no error and it'll function exactly the same. So that's basically all of the mates that need to be gone over. So now I'm going to show you how you can create polycarbonate pieces. This is very helpful because, especially if you have a laser cutter, you're going to want to create polycarbonates in CAD and then laser cut them later so that they're much more accurate and clean. So what I'm going to do is I'm going to go into the part studio. I'm going to create a sketch, and with the sketch, I can select one of three planes. I can select the right, the front, or the top. So here I'm just going to select the top since that's the easiest. And for creating polycarbonate pieces, there's a very specific method that is very efficient. So first, you're going to want to start out with creating a circle. And you're going to want to make this 0.164. That is um, the diameter size for a screw. It fits it perfectly with a little bit bigger than perfectly, but that's the size that you're going to want to use. You can go a little bigger, a little smaller. It probably won't matter, but I use that size every single time. And then you're gonna want to do is you're gonna want to make a 0.5 circle around that. That's the width of the C channel. If this is going on top of a C channel, just a regular C channel or 1x, then that'll be the width of that so that it will look clean when it's on there. Now you can see here, before we add this to the part studio, we're gonna want to make this whole part fixed. So this thing, it can move. It can move around, and we don't want that. We want it to be fixed. And you can see, if you go over to the top bar over here, you can see that it has a blue circle and a white dash. That means it's undefined, not fully defined. Now this can easily be fixed by either using the dimension tool. If you have two different dimensions like that, it'll make it black, and it's basically fixed because these values will change and this value will change, so it can't move. Or an easier way to do that is you can do you can go to the Fix tool by pressing Shift J and then select the little thing that turns to black and it still also can't move and it makes it fully defined. So we have this polycarbonate, or we have this sketch here. And what we're going to do is we're gonna keep that sketch. We're going to go to the extrude, and then all we have to do is just go to solid, new, and then click on this outer face right here. So once you click on that, it's going to immediately give it an inch. That's the default. But we're going to want to change that depth to 1/16, which will be the polycarbonate size. So we just have a regular circle here. And what we can do is we can go to back to our assembly. We can go to insert, go to current document. That's this current document. So all of the stuff you make here will be here. You can click on part one, which is the one we just created. I'll be inserted into the thing or into the document. And then we do the same exact thing with the Fastate that we did with the gears. And then we can go to any hole that we like. And since it's backwards, we just click that. And then that's on top of our C channel. And the reason we use 0.5 is just because it's a very good width or a diameter, and it is the most clean way to make polycarbonate pieces. So as you can see, this is just a circle. It's not really anything yet, but we can change this. And the easiest way to edit a polycarbonate piece is to be able to view the things around you. It would be much easier to make a polycarbonate piece if I could see this C channel, right? So we can actually do that by right-clicking on the polycarbonate piece. We can go and click Edit in Context. Now this puts us in the Part Studio, but it has the assembly displayed. You can change the contrast or the transparency, and you're able to do that. That makes it very easier. You can also use these lines if you need to. I wouldn't suggest doing that. You won't need to, but now that we go back into our sketch, we can edit this further. So let's say we want to extend this polycarbonate piece out to this hole right here. Now the easiest way to do this, or the best way to do this, to make sure everything is fixed and defined, we're going to want to hover over this. We'll have center point circle selected. We want to hover over this. And then if we just go up, it'll keep that line. And it'll basically, once I make this piece, I'll make it 1.164 again. Once it does that, you can see I'm trying to move my mouse, but it's only allowing it to translate up and down, but I can't move it side to side. This is because it locked it on that specific axis. So it's basically connected to this just on that axis of the part. So what we can do is, since I want it on this hole, we can use our dimension tool to click the inner circle of that, the inner circle of that, and then we can go 2 inches, because that's the distance from hole to hole, and that will put us on the hole that we wanted. Now we can do the same exact thing by making it 0.5, and now we've got the same exact thing that are 2 inches apart. So what we do here is, obviously we need lines going across. There has to be something to connect the poly. So we can make a line by creating the line, and a really neat way to do this is by first creating the lines. You can do that, and then we can go over to our tangent tool. This is going to make it tangent to the circle, so it's going to be connected to the circle, and that basically makes it attached on the circle. And then we can do that again, select, and we can do it right there. And that fixes it, so it's connected to both of them. This is very helpful for making sure that there's no gaps in between your lines, and also for just simplicity. It's very easy to create a line and then make it tangent to two circles, and you don't have to like extend a line out here and then go down here. It's very easy to just create one line, and it makes also makes sure that everything is fixed. You can see that this blue line or this line is blue, which means it's not fully defined. Now I'm going to do the same exact thing I did the other one, and now we have a full polycarbonate piece. So let's click on that, and you can see that it's still a circle. Well, that's because what we extruded on was just a circle. We didn't extrude it on the rest of these parts. It's only on this area right here. But we can actually expand this area by deleting these just this inner part of the circle. And you can do that using the trim tool by clicking M, and that'll trim off any excess parts. So if we want to take apart or take away this inner circle, we just click on it and it'll go away. And we can do the same to the excess lines. And our part is still fully defined. And once we click on it, it actually forms into a piece. So this is our polycarbonate piece created. So we can go to assembly, and now it's there. And you can extend it out this way, you can make curves, and you can do a whole lot of things. But I'll go further into making polycarbonate pieces in another video. Alright, so now I'm going to go over how you can make custom parts. Sometimes in CAD or in real life, you'll shave down parts or cut parts, and you it's very nice to have that ability to do that in CAD. And there's a very easy way to do that, and all you have to do is go to the search tool and search up derived tool. So this will basically bring a part into the part studio, which we can edit freely. So we can select part studio, and then we can go to other documents. And for this example, I'm going to use a gear. I'm going to take a 36 gear, and I'm going to put that into the studio. So now this is here. I can actually transform this gear however I want. I can move it using the transform tool. If I search that up, it's also located right here, but you can click on it, the entity, and then you can translate a line, distance, XYZ, however you want. I'm gonna go by distance. I'm gonna just move it over 1 inch, and then you have to select a plane, which I'll select the front plane just to move it over a little bit lower. So now, what I'm gonna try and do is I'm gonna try and remove this little area on one of the sides, just so that I can fit a nut right there. So what I can do is create a sketch, and then I can go over here, create a circle around it, and now that I have that sketch there, I can extrude it and go straight into the part. Now, what we'll do is we'll click the remove part. We'll drag it over here, and that will remove however much you want from the part. So being able to do this is, again, really important because there's always going to be areas in real life where you have to shave down a gear or shave down a screw. And to be able to do that in CAD to make sure what you're doing will actually work is very, very important. So that is basically it for the tutorial. I think I covered mostly basics. I'll be doing more videos that go a little bit more advanced in polycarbonate and also just the specific tools that you can use. So stay tuned for when those drop. And if you have any questions on this video, be sure to just comment down below and I'll either answer in the comments or make a video on it.